In this video, we're going to look at theorems about zeros of polynomial functions. And we begin with the Fundamental Theorem of Algebra. The Fundamental Theorem of Algebra says every polynomial function of degree n with n greater than or equal to 1 has at least one zero in the set of complex numbers. Every polynomial function f of degree n with n greater than or equal to 1 can be factored into n linear factors, not necessarily unique. That is, f of x equals some constant a sub n times x minus c sub 1 times x minus c sub 2 and so on times x minus c sub n. So what the Fundamental Theorem of Algebra is really saying is that if we have a polynomial function of degree n, then there will be n zeros of the polynomial in the complex number system. But some of those zeros may be duplicates. So we may have the duplicate of the same zero n times, but there will be n zeros if we count each of those separately. So for example, if you have a quadratic equation, the degree is 2, you're going to have two zeros, but you may get the same zero twice. If we have a cubic function, again, the degree there is 3, so you're going to have 3 zeros. Now you again may get the same zero all 3 times, or you may get 3 unique zeros. But that's basically what the Fundamental Theorem of Algebra is saying. You're going to have at least one. You could have up to n. They could be unique or they could be duplicates. Regardless, we will be able to factor it so that we have n factors such as this. But again, they're not necessarily unique. We may get the same factor repeated. Let's take a look at an example. So in this example, we want to find a polynomial function of degree 3 that has the zeros 2, 5i, and negative 5i. So based on what we've just learned, since these are our 3 zeros and it's degree 3, then our polynomial function is going to be some constant, which we'll call a sub n, times x minus the first zero, 2, times x minus the second zero, 5i, times x minus the third zero, which is negative 5i. Okay, so that's going to be some constant, a sub n, times x minus 2 times x minus 5i and x plus 5i. So this will be a polynomial function of degree 3 that has these zeros. Now as a general rule, we're going to want to multiply this out. And this a sub n could be any constant. So I'm going to begin by multiplying out the x minus 5i times the x plus 5i, and I'm going to just do that over here on the side. So if we do that, x times x is going to be x squared. X times 5i is going to be 5ix. Minus 5i times x is going to be minus 5ix. And minus 5i times plus 5i is going to be minus 25i squared. So I'm going to have a sub n times x minus 2 times. Now this, if I clean this up, the plus 5ix and the minus 5ix is going to cancel. These are conjugates, so that always happens. The outers and inners will cancel. But here we have minus 25i squared. Now remember, I squared is really negative 1. So I have negative 25 times negative 1, which is really going to be a plus 25. So we have x squared plus 25. And if we multiply then the x minus 2 times that, we're going to have a sub n times x squared will be x cubed. Minus 2 times x squared is minus 2x squared. X times 25 is 25x. Minus 2 times 25 is minus 50. So we have some constant, a sub n, times x cubed minus 2x squared plus 25x minus 50. So this is our polynomial function that has degree 3 and has zeros of 2, 5i, and negative 5i. And again, a sub n could be any constant. So it could be 1 times this, it could be 2 times this, it could be negative 15 times this. A sub n could be any constant. Usually on problems like this, we let a sub n equal 1. So if a sub n equals 1, then our function's going to be 1 times x cubed minus 2x squared plus 25x minus 50. And so this is the simplest polynomial function of degree 3 that has zeros of 2, 5i, and negative 5i.